This is Pluto, a fascinating and mysterious world that lies far beyond Neptune in the Kuiper belt. It was once considered the ninth planet of our solar system, but it was reclassified as a dwarf planet in 2006. Pluto had it coming from the beginning. It was like it was never really belong. Pluto's orbit crosses that of another planet, and that's no kind of behavior for a planet. Regardless, this did not diminish the interest in this extraordinary celestial body. When delving into the discussion of searching for life beyond Earth, Pluto emerges as an intriguing and perhaps surprisingly promising subject. Many traditional assumptions about the conditions necessary for life are challenged by recent discoveries on the surface and beneath the icy exterior of this distant world. And now, far exceeding expectations, stunning images captured by New Horizons and James Webb are shaking our previous conceptions of Pluto, revealing it as much more than a mere dwarf planet that's baffling scientists because they don't fit in the normal sequence. Join us as we dig deep into secrets hidden in Pluto's subterranean. Let's get the ball rolling with a little question to test your knowledge of the forgotten planet. We all know Pluto is small, but how small is it compared to Earth? A. 1 to the power of 3, B. 1 to the power of 4, C. 1 to the power of 5, D. 1 to the power of 6. What is your option? Don't forget to share your thoughts in the comments below. Pluto, once considered a remote and inert mass of ice, now appears to conceal a dynamic and complex subterranean world. The hypothesis of a liquid ocean beneath its icy crust has gained traction, supported by the presence of extension fractures and the lack of significant craters in some regions, suggesting more recent geological activity than expected. The idea of an ocean beneath Pluto's surface is not only the result of recent speculations. Scientific publications dating back to 2006 hypothesized the presence of underground oceans in celestial bodies beyond gas giants, including dwarf planets like Pluto. However, the New Horizons mission has provided new details and extraordinary images that have breathed life into these theories. When NASA's New Horizons spacecraft reached Pluto, it gave scientists their first detailed look at one of the most mysterious objects in the solar system. In addition to wonders like soaring mountains, ice volcanoes, and a giant heart-shaped basin, images beamed back by the probe revealed a surface marred by a network of fissures and a notably spherical shape. For some scientists, those last two discoveries are hints that something even wilder may be hidden inside the tiny world. Shortly after the first images of the near side arrived at Earth, researchers spent a lot of time unlocking the secrets of this dwarf planet. Francis Nimmo, a planetary scientist at the University of California, Santa Cruz, and his colleagues then spotted that the left ventricle of Pluto's heart, an icy basin churning and flowing with massive glacier known as Sputnik Planum, was in a strange place. It is aligned almost exactly opposite Pluto's largest moon, Charon. It could be an accident, but the likelihood of that is a mere 5%. Instead, models suggest that when the basin formed, an underground ocean began to well up into the chasm. Afterward, nitrogen gas in Pluto's atmosphere condensed and froze in the frigid basin. The weight of the new water and ice created a heavy load that tipped Pluto into its current alignment. As told, the idea of a subsurface ocean has existed for some time, but the far side images have helped to bolster this idea. Some of the strongest evidence comes from a feature known as chaotic terrain, a jumbled mess of ridges, cracks, and plains on the exact opposite side of Pluto from Sputnik Planum. Scientists have seen such pairs before on Mars, Mercury, and Europa, one of Jupiter's moons, where they suspect that a collision from an asteroid or a comet sent seismic waves racing through and around the body. Once those quakes converged on the opposite horizon, they tore up the surface in ways resembling what appears on Pluto's far side. To test the origins of this chaotic terrain, Aidan Denton, a graduate student in planetary geology at Purdue University in West Lafayette, Indiana, simulated how an asteroid impact would send shock waves across the dwarf planet. The work, presented virtually at the Lunar and Planetary Science Conference, verifies that such a collision would have created the terrain. However, with one caveat, it would have been possible only if Pluto had a 150 kilometers thick subsurface ocean of liquid water. As Oliver White, a planetary scientist at the SETI Institute in Mountain View, California, who built a geologic map of the far side but was not involved in the study, argues, although the feature does seem to resemble those seen elsewhere in the solar system, the resolution in the image is low, and other scientists agree. But perhaps we will never know until we go back someday. Regardless, Pluto has some geological oddities, in particular, a large number of cracks discovered on the far side that add support to the existence of a hidden ocean and even sheds light on how it formed. Scientists who have theorized about Pluto's ocean have long assumed that it had a cold start, and that the ocean was frozen when the dwarf planet formed. Later, it would have melted under the heat provided by decaying radioactive elements in its rocky core. In this scenario, the ice would have contracted as it melted, leading to ripples on the surface, similar to the wrinkles that appear on an apple left in the refrigerator. Then, the ice would have expanded as it refroze, resulting in cracks on the surface. If this scenario is correct, images of Pluto's surface should reveal older wrinkles and newer cracks. But New Horizons photographed only cracks, suggesting that the dwarf planet's ocean began as a liquid and has partially frozen over time. In particular, images of the far side reveal a giant crack that stretches up the near side of Pluto. It now seems to run across the North Pole and back down towards the South Pole on the far side, thus wrapping around the entire dwarf planet. It's similar to the East African Rift system, which is cleaving that continent in two. Unlike the one on Earth, Pluto's rift is not a sign of shifting continents but is probably a scar from the freezing and ever-expanding ocean. Because the crack is extremely old, it is clear that the liquid ocean began to chill immediately. And if true, the ocean might even be ripe for the existence of life. Observations of water that had probably gushed out of the ocean on the near side show that it is red, hinting that it's stained with organic molecules. Although that might seem impossible on a world such as Pluto, laboratory experiments have shown that radiation similar to solar wind or cosmic rays can create complex organic matter that is reddish-brown. And if ammonia is present, it is possible to form molecules that are crucial for life, including the bases present in RNA and DNA. So when Dale Cruikshank, a planetary scientist at the NASA Research Center in Moffett Field, California, and deputy lead of the New Horizons composition team, and his colleagues revealed in the journal Astrobiology that Pluto's near-side ices were both red and laced with ammonia, it was a crucial sign that the orb might be replete with organic molecules. The theory, which has gained a lot of traction among planetary scientists, doesn't mean that life got a start on Pluto, Cruikshank says. But that if it were introduced to Pluto, it could survive. In the words of Kathy Kinn, a planetary scientist at the Southwest Research Institute and a deputy project scientist on the mission, before New Horizons got to Pluto, I would have never in a million years expected that there would be an article about Pluto in Astrobiology. Results from the far side bolster this theory. They reveal a red band, probably of organic material, that stretches across the equator, corresponding to an area with the most sunlight and the most temperate vicinity. And that's a landmark discovery because, basically, you need liquid water, organics, and a source of energy to support life. And now, with these groundbreaking discoveries, we know that not only is there a pretty good case for liquid water, but we also have a case for organics on Pluto. In other words, that's 2 of the 3 boxes checked, which is a very important step forward. In a piece of interesting news, UFO hunters believe NASA is hiding mysterious artificial structures on Pluto after spotting some very suspicious and mysterious structures on an image of the dwarf planet. For instance, you can see a bizarre smoky trail stretching 10 miles across the surface of the dwarf planet. But while some people believe that the smoky trail could be associated with alien life, NASA claims the anomaly is a natural phenomenon. According to NASA, the 10-mile smoky patch is sunlight reflecting off a methane cloud. But under UFO hunters' views, this isn't a cloud at all, this is a massive smokestack coming from the surface, coming from somewhere. It is not hovering over the surface completely. Many people believe the patch of smoke appears to be originating from a hidden building on Pluto. In other words, it could be a piece of evidence for the existence of life on Pluto. What's interesting is similar structures have also been found on Mercury and Mars, and conspiracy theorists believe that the structures on the dwarf planet's surface are known to NASA, and that the agency is just keeping them under wraps. Notably, beyond helping to explore Pluto's potential for life, the far-side measurements have generated a number of mysteries. When the images from New Horizons first reached Earth, scientists noticed a bizarre terrain that consisted of skyscraper-sized shards of ice along the near side's easternmost region. These evenly spaced ridges are only a few kilometers apart yet rise sharp and knife-like into the sky, occasionally soaring as high as 1 kilometer, roughly 3 times the height of the Empire State Building in New York City. They can be as long as 30 kilometers. Well, that might be a nightmarish landscape to try and navigate, but they were nothing more than a blip on the map until scientists caught a glimpse of the far side. Although the latest map is blurry, it's clear that the bladed terrain wraps all the way around the far side and pops out again on the western edge of the near side, in a region that was previously overlooked. On the far side, they cover an area that is 3.5 times larger than their extent on the near side, making them one of the biggest mysteries on Pluto. Spectral data reveal that the blades are composed of methane ice and create a belt around the equator, at least on plateaus and mountains. But how they form remains a mystery. It might be that methane froze out of the atmosphere in the same way that frost freezes on the ground on Earth, or perhaps they are vestiges of an old layer of methane ice that was eroded by the glaring sunlight. Some researchers have focused on the latter explanation because the sharp ridges resemble structures that form in the high Andes, albeit on a radically smaller scale. But co-author Tanji Bertrand, also at the NASA Ames Research Center, argues that it is hard to use that process to explain all of the blade's characteristics. Moreover, the bladed ridges seem to be ancient features that have grown over long stretches of time. Not only would it take tens of millions of years for ice to either condense or sublime into such tall features, but their location spans a wide range of latitude. Changes in the past climate might explain how the bladed terrain's location moved and even formed, but there are plenty of details that need to be teased out. Up to now, although it has been close to a decade since NASA's New Horizons spacecraft visited Pluto, the dwarf planet continues to reveal itself as a surprisingly complex world. Scientists studying spacecraft data of an unusual crater near a bright heart-shaped region on Pluto called Sputnik Planum say they may have found a supervolcano that likely erupted just a few million years ago. That might sound like an incredibly long time ago, but cosmically speaking, it's pretty recent. For context, the solar system is more than 4.5 billion years old. Instead of molten rock that blasts out of Earth's volcanoes, however, the 44 kilometers wide Cadzi crater appears to have spewed ice lava onto Pluto's surface in a process known as cryovolcanism. The process, which also unfolds on the moons of gas giants in our solar system and likely created other mystifying terrains on Pluto, is thought to have thrust water from the world's hidden subsurface ocean onto its surface, reshaping it across millions of years. Volcanoes require some sort of heat source to blow up, so the recent activity on Pluto suggests there is more heat remaining in the dwarf planet's interior than previously thought. Researchers analyzed images New Horizons had clicked of the Cadzi crater, which resides northeast of Sputnik Planitia. While at first, the crater looked similar to those left behind by meteorite impacts, it appeared to be missing a central peak otherwise expected for these geological phenomena. It also seemed slightly elongated, consistent with movements caused by tectonic forces from within Pluto. Most of Pluto's surface is blanketed with methane and nitrogen ice, so the tip-off that Cadzi is different from the rest of Pluto's surface is the strong presence of water ice around the crater. Study lead author Dale Cruikshank, a professor at the University of Central Florida, told Space.com, the water ice stands out clearly from the methane ice that covers much of the planet's surface. Pluto's axis is tilted at a sharp 120 degrees, which means it spins almost on its side, leading to dramatic changes in climate as it circles the Sun. As a result, methane ice sublimates into a haze of hydrocarbons in the dwarf planet's atmosphere, some of which rain down as snow and coat its surface. Over Pluto's 4.6 billion year lifetime, scientists estimate this methane ice blanket must have gotten at least 14 meters thick. Even a centimeter or two of this organic smog would mask the water ice spectral signature we observe, Cruikshank said. Such a layer would have formed in just 3 million years. This led Cruikshank and his team to conclude that Cadzi was alive only a few million years ago. Scientists don't fully understand how cryovolcanic activity works on Pluto. The world is so small that it would have lost all heat from its formation long ago. One possibility is the dwarf planet contained radioactive elements in its core, which released heat while decaying. Although previous research suggested there just may not be enough of these elements to power up Pluto, however, whatever the heat source might be, something appears to be keeping Pluto's subsurface ocean from freezing. After all, Pluto continues to surprise us with its complexity and potential opportunities to host life. Its geological and atmospheric history, along with the alleged presence of an underground ocean, make this dwarf planet a fascinating subject for future astronomical research. In a vast and mysterious universe, Pluto reminds us that there are still many secrets to unveil. Maybe a future mission dedicated to exploring Pluto more thoroughly could provide additional details and answers, opening new chapters in our understanding of the outer solar system. While scientists are trying their best to unlock the mysteries of Pluto, a brand new study has just suggested that the thickness of ice shells covering our solar system's ocean-bearing moons could provide hints